So the title of today's lecture is called Molarity. So just make sure you guys jot that down. And we're going to be talking about what molarity is, but this is a way of measuring that's going to be very prevalent going forward. Okay, so before we talk about molarity, we got to get some definitions out of the way for the unit. The first definition is this one right here, solution. Okay, and in chemistry, solution isn't the answer to a problem. It's a homogeneous mixture, basically a mixture that just kind of looks the same throughout, okay, of two or more substances. Okay, so a solution is basically when you mix things together. Typically, you're going to be mixing a chemical with water in this unit, and that's what we call a solution. It's basically a chemical dissolved in water. All right, so a solution is made out of two different things, and those are the other two definitions that you'll need for today. The first thing is called a solute, and the solute is just whatever is getting dissolved. Okay, so solute is whatever is getting dissolved, and then the other part of a solution is called a solvent, and that's whatever is doing the dissolving. Okay, so easy way to think about this, a common solution that you guys might be familiar with is like salt water, right? Okay, and salt water is made out of two things, right? So the thing that's being dissolved is going to be your salt. So that's going to be your solute. And the thing that's doing the dissolving is water. It's basically whatever you have the most of. And so that'll be your solvent. So that's an easy way to distinguish between the three definitions that we'll need for this unit. Solution is whatever the mixture is. Solute is what's getting dissolved. And the solvent is whatever you have more of, whatever's doing the dissolving. And for our unit, the solvent will 99.9% of the time just be water, okay? So it's usually when we're dissolving a chemical inside of water. All right, so let's move on from those definitions. So let's talk about molarity now. So molarity is in chemistry is a way that we measure something called concentration. So just make sure you jot that down. And concentration isn't like when you try to focus really hard. An easy way to think about concentration is how strong a mixture is. So when you guys drink certain liquids, right, you can think of it as how strong or how weak something is. So something that's very sweet, you would consider that high concentration because it has a lot of sugar dissolved inside of it. But something that is less sweet is going to be lower concentration. All right, guys, so just to kind of help us understand concentration a little better, we're going to go through just one or two examples. You guys don't need to copy this down. This is just kind of for you guys to understand what concentration is. But let's take a look at these two solutions and just figure out which one is more concentrated. So let's say we have solution one, which is going to be a container that has 200 mils of water. And then you're just going to put 1 scoop of salt in there, okay? The second solution is basically the same thing. It's going to be 200 mils solution again. But this time you put 2 scoops of salt in there. So which one do you think is more concentrated, 1 or 2? Yeah, obviously 2, right? And the reason why is because you put more salt inside of that solution, right? So that's pretty much what concentration is. It's distinguishing between which one has more dissolved inside of it, okay? Any questions about that example? Okay. So that's our first example, but let's take a look at another one to talk about concentration. Okay, so let's say that we're comparing this time another solution. So solution one is the same. You have 200 mils of water and you have 1 scoop of salt inside of it. Okay, that's solution one. Okay, but solution three, this one is going to be a lot bigger. It's going to be 200,000 mils of water. Okay, so a lot more water, and we put 2 scoops of salt in it. Which one do you think is more concentrated? Yeah, 1. Okay, but why 1? We have more salt inside of solution 3, don't we? Yeah, we have more salt, but what's the difference?
The ratio.
Yeah, the ratio, right? The size of the container. So just keep that in mind. Even though we have more salt inside of solution 3, there's more stuff dissolved. It's spread out a lot thinner, right? Because there's a lot more volume. And so that also makes a difference in terms of concentration. And so just because you have a lot more or you have more dissolved in something doesn't make it more concentrated. The other thing that matters is also the volume of the solvent. Okay. All right, so which leads us into the equation that you'll need. All right, so the way that we measure concentration, like we said, is molarity. And the symbol for molarity is just capital M. Okay, so the equation that you'll be given on your exam and your will be this one right here. Capital M equals moles divided by capital L. And that's pretty much the same thing as this right here. Molarity is moles of solute divided by liters of solution. So basically, how many moles of your chemical is dissolved in your solution, okay? Just make sure you guys jot at least this one down right here. The capital M equals moles over liters. But if you want the clarification is right here, okay? Molarity is the moles divided by liters. And so you guys can probably already see how we're going to bring stoichiometry into this. We got moles, so we'll need stoichiometry. All right, so the first thing I want to clarify about this equation is the numerator, the moles of solute. This is basically how much of the chemical you're dissolving. And if you notice, it's measured in moles, right? But when we start doing our labs going forward, on the scale, we don't measure things in moles, right? We typically find the weight of something in grams. So just going forward, just keep that in mind. You will have to convert your grams into moles before you can find molarity. So just keep that in mind. Usually you'll start with grams, you'll turn it into moles, and then that's how you can find molarity. And we'll do examples of this. So if that's kind of confusing, I know it's a long break, don't worry about it. But just keep that in mind. You'll turn grams into moles. The second thing is the denominator, the number on the bottom, always has to be in liters. Okay, but we're working in a high school chemistry lab, so you're not making a ton of the chemical. So usually the measurements we'll be using will be in milliliters. And so you'll have to convert that into liters before you plug it into the equation. So just some things to keep in mind, just to give you a heads up so you don't do the calculations incorrectly. The top has to be in moles. So if you start with grams, turn it into moles. And the bottom has to be liters. So you have to turn it into liters from this conversion. Okay. All right, so let's jump into a couple problems just to kind of warm us up. And then we'll get into some tougher ones, okay? So let's take a look at number one. And in number one, we are going to learn how to calculate molarity. So question's very simple. It's asking what is the molarity? So we're looking for capital M of a 1.25 liter solution that contains 0.8 moles of this compound right here, AgCl2. Okay, so pretty simple question. We're looking for molarity, so we can use this equation right here. So we're going to just write down capital M is equal to moles divided by liters. All right, and just let's look at the problem and see if we have the numbers for moles and liters. So if we look at the problem, we can see that we have liters, right? 1.25. So 1.25 liters goes on the bottom, and we don't need to change anything about it because it's already in capital L. And then for the top, we have moles already. It's 0.8 moles. So number one's pretty easy. Want to start with the easy one. All you have to do is punch this into your calculator. Any questions how we plugged it into the equation though? Hopefully not too bad. All right, so I'll give you guys about 30 seconds to finish copying that down and see if you can punch it into your calculator. See if you can do this correctly. I know it's been a while since you've probably done a calculation like this. So punch it in and see if you guys can get the answer. And then the answer is the unit of measurement is gonna be in capital M, so molarity. So take a second to do that, and then we'll double check if you guys got it. Alrighty guys, so let's punch it into the calculator, see what you guys got. So when you have a fraction, very simple, you just do top divided by bottom. So you do 0.8 divided by 1.25. So your final answer will be 0.64. Okay, so 0.64, and the unit of measurement will be in molarity because the question's asking what's the molarity. Okay, so pretty simple. Any questions on number one? All righty. All right, so let's skip number two because it's also very easy, and I think you guys can do a problem that's a little bit harder. So let's skip number two and jump to number three. Okay. All right, so I'm gonna give you guys about 2 minutes. See if you guys can try number 3 with the person next to you. I'll write the equations that you will need. So just remember, molarity is moles divided by liters, and just remember that 1 liter is equal to 1,000 milliliters. Okay, so just keep that in mind. So see if you guys can figure this out. This is a little bit different from the one that we just did. See if you could find that difference and fix it before you punch it in. All right, take about 2 minutes to do that. All right, so in this problem, we are looking for molarity again. So we're going to be using this equation. Capital M is moles divided by liters. And so we're just going to write it down and let's see if we can plug in our values. Okay, so if we take a look at this problem, we have 2 other numbers that we're working with, 9,700 milliliters and 1.2 moles of ZnBr2. Okay. All right, so we're going to plug in the numbers that we have into the equation. So moles is pretty simple, right? It's just 1.2 moles. So we're going to put 1.2 on the top. So the top's going to be 1.2 moles. Okay, but hopefully you guys notice the other number that we have a problem, right? Because it's not in liters, it's in milliliters. And so what we have to do is we need to turn this into liters before we can plug it into this equation. So the conversion is 1 liter is 1,000 milliliters. So what you have to do is just divide by 1,000. Okay, an easy way to do that is just find the decimal and move it 3 times to the left. But if that's confusing, just plug it into your calculator. Okay, so that's going to be 9.7 liters. Okay. Just make sure you turn milliliters into liters, and then we can plug it into our equation. All right. Just be very careful of that going forward, because when we do our labs going forward, you're going to get the measurements in milliliters like 100% of the time. So you'll have to convert it into liters. Just divide by 1,000. Okay. All right, so the math is pretty easy. Just top divided by bottom, 1.2 divided by 9.7. And then you'll get a final answer of, and then I'm going to round it off to 0.12, and it's still going to be in molarity. Okay. There you go. That's your answer for number 3. All right, any questions on that one? Easy peasy? All righty, great. Okay, I'm going to give you guys 3 minutes to try number 4 again with the person next to you. This one is a little bit tricky again. If you guys notice, you're still finding molarity, but we have milliliters again. But this time, instead of moles, I gave you grams. Okay, so you'll have to do 2 conversions before you can plug it into the equation. And since it's been a long break, just a reminder, when you are turning grams into moles, you have to use the molar mass. Okay, so that's why you need your periodic table. So if that's confusing, look back at your notes on how to do that. But the chemical that we're working with is salt, table salt, and that's going to be NaCl, sodium and chlorate. So take a second, see if you guys can figure that out with the person next to you. I'll give you guys about 3 minutes, and then we'll go over the answer together. All right, so number 4, we're trying to find molarity. So let's use the equation again. So molarity, like we said earlier, is capital M equals moles divided by liters. The problem is, for both the numbers that we have, 100 mils and 3 grams, neither of them just go into the equation. We need to do some conversion. So let's do the easy one first. The easy one is 100 mils, right? All we have to do is divide it by 1,000, or move the decimal 3 times to the left, and that gives us our liter. So it'll be 0.1 liters. So hopefully that part wasn't too hard. Okay. All right, the one that's a little bit more time consuming is the 3 grams of NaCl. So since it's in grams, we have to turn it into moles. So what we're going to be doing is we're going to be turning 3 grams of NaCl, and we're going to be turning it into moles. But to do that, we need to use the molar mass. So what we're going to do is look at the periodic table, and let's find the molar mass of NaCl first. So NaCl is obviously made out of Na and Cl. So if you notice, Na is 22.99, and then Cl is going to be 35.45. So plus 35.45. So the molar mass of NaCl is 58.44. Okay. All right. So I'm gonna just jot that down. So 58.44, and just keep that in mind that it's grams per mole. Okay. All right, so we're gonna set up a fraction. And then if you guys remember from before break, whenever you want to get rid of something on a fraction, you put it on the bottom. And we want to find moles right now, so we put moles on the top. And then all we have to do is plug in the molar mass right here. Okay, 58.44 is next to grams, so we put 58.44 on the bottom. And then it's per 1 mole, so we put the 1 on the top. And that's how we can get the conversion. Okay, so I'll pause right there because I know that was a bunch of steps. Do you guys have any questions on any of those steps? Molar mass, fraction? All right. All right, so to find moles, we just need to do 3 divided by 58.44, and that'll give us an answer of 0.05, and you can just leave it there, moles. And now we can finally plug in everything into this equation, and we're all done. Okay. All right, so for the top of the fraction, we need to put in moles. We got 0.05 moles for the top. And then we're going to divide that by 0.1 liters. So you just punch it into your calculator, and then that should give you a final answer of 0.5 molarity. And so this is basically telling us if you dissolve 3 grams of salt inside a 100 ml solution, the molarity is going to be 0.5. Okay. So that's the strength, that's the concentration of that mixture. So the second part of today's assignment, or the second type of problem you'll be doing, is going to be where you need to figure out how much of a chemical, how many grams of a chemical you need to dissolve in order to make your solution. Okay, and this is going to be what you're doing in labs going forward. I'm not going to be making your solutions for you, so it's very important that you guys know how to do this calculation, or the solutions you make will be all messed up and your lab's going to come out really weird. Okay, but calculation's not too bad. All right, so let's try number 6 together, and then yeah. So this is what your Canvas quiz, the problems on your Canvas quiz are going to be very similar to number 6. So again, if you have any questions, please let me know. But let's jump into it. So the problem is asking how many grams of CaCl2, so the chemical that we're working with is CaCl2, are needed to produce 1,000 mils of a 0.2 molarity solution. And I forgot a word. Sorry about that. Okay, so those are going to be the 3 things that we're looking at. Okay, so we're looking for how many grams of CaCl2 we need to produce 1,000 mils of a 0.2 molarity solution. So basically, if we were doing this in real life, we'd have a container. Okay, we want the solution to be 1,000 milliliters. We're basically asking how many grams, how much CaCl2 we need to weigh out in order to make this solution 0.2 molarity. That's pretty much what we're trying to figure out. Okay. All right, so let's do the math now. So very simple. Since we have molarity and milliliters, we're probably going to be using this equation right here. So let's write down this equation and see what we can get. So capital M is equal to moles divided by liters. Okay. Alrighty, so what we're gonna do is we're just gonna plug in the numbers that we have into this equation. So if you guys notice, we have molarity, right? It's 0.2. So we're gonna plug in 0.2 for the molarity, capital M, is equal to, and if you notice, we don't have anything for moles yet, right? So let's just leave that as moles for now. So we're gonna put moles on the top, divided by liters. Now we have 1,000 mils, and so we talked about how earlier if you just divide it by 1,000, you get liters, and so 1,000 divided by 1,000 is 1. So this is going to be 1 liter. So we're just going to put in 1 liter here on the bottom. Okay, so that's all the numbers that we began with, and this is the equation that we have. All right, so far so good. Where we got these numbers, how we plug them in. Okay, so if you take a look at the problem, it's asking us to find grams of this chemical. Now, we don't have grams anywhere on this in this equation. However, if you guys notice, the thing that we are missing is moles, right? And if we think about it a little bit, if you find moles, it's pretty easy to turn it into grams, right? It's basically the reverse of what we just did in the previous problem. All we have to do is find the molar mass. We set up that fraction again, and we can convert moles into grams. So the first step in this type of problem is first we want to find the moles of our chemical. So we're finding the moles of CaCl2. Now the math for this is really easy. Okay, let's pretend this is your algebra class for right now. Instead of moles, let's just put x. Okay, if you are solving for x, it's on the top of a fraction and something's on the bottom. All you have to do is just multiply by the bottom number on both sides. That way you can cancel this out, and that'll allow you to find the number on the top. So your moles of CaCl2, all you have to do is multiply both sides by 1. And so if you guys do that, 1 times 0.2 is going to be 0.2. So your moles of CaCl2 is equal to 0.2. All right, so once you have your moles of CaCl2, all you have to do now is turn it into grams. So what we're going to do is we're going to set up a fraction again. So 0.2 moles. Okay, you want to get rid of moles, so we put moles on the bottom, and you're looking for grams, so you put grams on the top. And all you have to do is plug in the molar mass into this fraction, and you're all done. So I'll give you guys about 2 minutes. See if you guys can go on your periodic table, find the molar mass of CaCl2, see if you can plug it in, and get your final answer for grams. Okay. Alrighty, so let's go over the answer number 6. So we need to find the molar mass of CaCl2. So let's go to the periodic table. So CaCl2 contains 2 chlorines. So we got 35.45 times 2. And then we got Ca, so we're going to go to the other side of the periodic table. Okay, Ca is right here, so we're just going to add 40.08. So the molar mass of CaCl2 is 110.98. Okay. Pull up the calculator. So the molar mass is 110.98. And if you guys remember, it's going to be grams in 1 mole. So if you guys notice on the top of the fraction is where grams is this time. So we're going to put 110.98 on the top. And then we're going to put 1 on the bottom. And so for your calculations, very simple. You just multiply numbers on the top. So 0.2 times 110.98. And you get your final answer of 22. Let's round it up to 2. Okay, if you wrote 22.19, 22.196, again, as long as it's close, you're totally fine. All right, so what all these calculations are basically telling us is that if you want to make a solution, so let's say, and this is what we're going to be doing in our future labs, let's say you're trying to make a solution that is 0.2 molarity. Okay, CaCl2. And the size of the container or the solution is 1,000 milliliters. Well, in order to make that, what you need to do is you need to put in 22.2 grams of CaCl2 and then just fill up the solution to 1,000. Okay, so we're going to talk about that more in detail when we meet on Friday. But that's basically what the purpose of this calculation is, to figure out how much of a chemical you need to dissolve in order to make the solution that you want. Okay, so here, since I want to make 1,000 mils of a 0.2 molarity solution, I need to put in 22.2 grams of CaCl2. Okay.